In this example, we want to find the solutions to the radical equation the square root of x plus 7 equals the square root of 4x plus 13 minus 3. Now, what makes this problem different from the last one? Again, we have the square root of 4x plus 13 minus 3 on the right-hand side. So the square root is not by itself. Like last time, we can try adding 3 to both sides, which gives the square root of x plus 7 plus 3 equals the square root of 4x plus 13 minus 3 plus 3, which is just the square root of 4x plus 13. Now the right-hand side just has the square root. But to keep the equation true, we need to square both sides. Squaring the right, we get to square the square root of 4x plus 13 by itself, which is great. But to square the left, we need to distribute the square root of x plus 7 plus 3. So adding 3 did not help the problem of needing to distribute. This just moved the problem from the right-hand side over to the left-hand side. So although we don't have to, let's just go back to the original. Since we saw that trying to add 3 to both sides did not help, let's just try squaring both sides. This gives us the square root of x plus 7 squared on the left and the square root of 4x plus 13 minus 3 all squared on the right. Now on the left, the square root of x plus 7 squared is just x plus 7, which is nice. But on the right, we need to square this out. Please click the link to the right to see this process done. Squaring the square root of 4x plus 13 minus 3 gives us 4x plus 22 minus 6 times the square root of 4x plus 13. And on the left, we still have x plus 7. Now notice our problem has gotten a little bit better, because before we had 2 square roots to work with, but now our equation only has 1. So we want to square the square root of 4x plus 13, which means we need to clean up the right-hand side. We can start by subtracting 4x plus 22 on each side. This gives us x plus 7 minus 4x plus 22 equals 4x plus 22 minus 6 times the square root of 4x plus 13 minus 4x plus 22. Now 4x plus 22 minus 4x plus 22 is just 0. So on the right, we have negative 6 times the square root of 4x plus 13. While on the left, we have x minus 4x, which is negative 3x, plus 7 minus 22, which is negative 15. Now, we can divide both sides by negative 6 to get the square root by itself, but we don't need to because of distribution of exponents over multiplication. What I mean here is if we have a times b to the n, that equals a to the n times b to the n. So using this on the right-hand side, we have negative 6 times the square root of 4x plus 13 squared equals negative 6 squared times the square root of 4x plus 13 squared, which is what we wanted, to square the square root of 4x plus 13. And computing this, we have negative 6 squared is 36, while the square root of 4x plus 13 squared is 4x plus 13. Now let's use this to finish solving the equation negative 3x minus 15 equals negative 6 times the square root of 4x plus 13. Squaring both sides, we get negative 3x minus 15 squared equals negative 6 times the square root of 4x plus 13 squared. On the left, we need to square out this polynomial. Doing that, we get 9x squared plus 90x plus 225. If you'd like to see the steps of this done out, you can click the link above. Now on the right-hand side, we already saw that negative 6 times the square root of 4x plus 13 squared is negative 6 squared, which is 36, times the square root of 4x plus 13 squared, which is 4x plus 13. And distributing, we have 36 times 4, which is 144x, plus 13 times 36, which is 468. So we're left with the equation 9x squared plus 90x plus 225 equals 144x plus 468. Now we had to do a lot of work to get here, but we now have a quadratic equation, which means we can solve it as long as we get 0 on one side. To do this, let's subtract 144x plus 468 from both sides, giving us 9x squared plus 90x plus 225 minus 144x plus 468 equals 0. In simplifying the left, we have 90x minus 144x is negative 54x, and 225 minus 468 is negative 243. So we have the quadratic equation 9x squared minus 54x minus 243 equals 0. Now we can solve this equation as it is using the quadratic formula, but we can make things easier if we divide both sides by 9. On the right dividing by 9, we just get 0. But on the left, we have 9x squared divided by 9 is just x squared, minus 54x divided by 9 is negative 6x, and 243 divided by 9 is 27. So we have the equation x squared minus 6x minus 27 equals 0. We were able to do this simplification because all of our terms were divisible by 9. And now we can solve x squared minus 6x minus 27 equals 0 because it's just a quadratic. So we've whittled down our original problem of the square root of x plus 7 equals the square root of 4x plus 13 minus 3 to just needing to solve the quadratic x squared minus 6x minus 27 equals 0. We can do this either by factoring or using the quadratic formula. Whichever way you'd like to see it done out, you can click the link now. Whether we factor or use the quadratic formula, we get that our solutions are x equals negative 3 and x equals 9. But remember, we need to check if these are solutions to our original equation. Checking x equals negative 3, the left-hand side is the square root of negative 3 plus 7, which is the square root of 4, which is 2. While the right-hand side is the square root of 4 times negative 3 plus 13 minus 3. 4 times negative 3 is negative 12, plus 13 is 1. So under the square root we just have 1 minus 3. And the square root of 1 is 1, and 1 minus 3 is negative 2. So since the left-hand side is not equal to the right-hand side when x equals negative 3, we get that x equals negative 3 is not a solution. What about x equals 9? With x equals 9, on the left-hand side, we have the square root of 9 plus 7, which is the square root of 16, which is 4. While on the right-hand side, we have the square root of 4 times 9 plus 13 minus 3, which is the square root of 36 plus 13, which is the square root of 49, and still minus 3. Since the square root of 49 is 7, we have 7 minus 3, which is 4. So since the left-hand side equals the right-hand side at x equals 9, we get that x equals 9 is a solution to our problem.